May 2nd, 1945, 3:47 p.m., Peenemünde Rocket Research Center, northern Germany. Dr. Wernher von Braun stood among the ruins of his life's work, watching American soldiers search through partially destroyed laboratories. At 33 years old, he was technical director of the world's most advanced rocket program, the V-2, the first ballistic missile, the weapon that had terrorized London for 8 months. The Americans know nothing about rockets. He'd told his engineering team just weeks earlier as Soviet forces approached from the east. They're 20 years behind us. Their rocket programs are amateur efforts, university professors with small test stands. They can't possibly understand what we've built here. The V-2 represents scientific achievement they couldn't replicate in a generation. His deputy, Dr. Arthur Rudolph, had agreed enthusiastically. American rocketry is primitive. They test small solid fuel rockets for short-range artillery. They have no liquid fuel experience, no guidance systems, no understanding of supersonic aerodynamics. Even if they captured our facility intact, they lack scientific foundation to utilize our knowledge. What Dr. von Braun didn't know, what German scientific pride had prevented him from discovering, was that at that exact moment, 340 miles away at Nordhausen, American soldiers were loading captured V-2 rockets onto trucks. Not to study, not to analyze, to ship to White Sands, New Mexico, where American engineers had spent 4 years preparing to exploit exactly this technology. And 12 miles from where von Braun stood, Major Robert Staver of U.S. Army Ordnance was reviewing a list of German rocket scientists to capture. Von Braun's name was at the top with a note. Top priority, this man knows more about rockets than any American, but we have infrastructure to use his knowledge immediately. The woman partially responsible for that infrastructure was Dr. Helen Williams, 41, aeronautical engineer who'd spent 3 years at California Institute of Technology, developing liquid fuel rocket engines while German scientists laughed at American amateur efforts. Her team had just received orders. Prepare to receive captured V-2 technology and integrate it with American programs. In exactly 3 months, von Braun would be working for the U.S. Army at Fort Bliss, Texas, teaching Americans everything he knew about rockets. And within 15 years, those primitive American rocket programs would put a man on the moon using technology that began with German V-2s but evolved far beyond anything German scientists had imagined. The laughing was about to stop forever. To understand German scientific arrogance, you need to understand the genuine revolutionary nature of their rocket program and why it seemed impossibly advanced compared to Allied efforts. V-2 rocket, Vergeltungswaffe 2, Vengeance Weapon 2. Height, 46 feet. Diameter, 5.5 feet. Weight, loaded, 27,600 pounds. Warhead, 2,200 pounds Amatol explosive. Range, 200 miles. Maximum altitude, 50-plus miles, first man-made object to reach space. Speed, 3,500-plus miles per hour, Mach 4.6. Propulsion, liquid oxygen and alcohol water fuel. Thrust, 56,000 pounds. Guidance, gyroscopic, pre-programmed trajectory. Production, 6,000-plus rockets manufactured. Cost, 100,000 Reichsmarks per rocket, $40,000, equivalent to $670,000 today. Revolutionary technologies. Liquid fuel rocket engine. First operational liquid fuel rocket, far more powerful than solid fuel alternatives. Supersonic flight. First operational supersonic missile. Ballistic trajectory. Launched vertically, flew above atmosphere, re-entered at supersonic speed, unstoppable by any defense. Gyroscopic guidance. Primitive but functional inertial guidance system. Turbopump technology, high-speed pumps delivering fuel at extreme rates. Aerodynamic design, stable flight at supersonic speeds through innovative fin design. The V-2 represented a quantum leap in military technology. When operational V-2s began hitting London in September 1944, British and American scientists were stunned. Allied rocket programs, 1944. United States. Bazooka, solid fuel, short-range anti-tank rocket, effective but primitive. JB-2 buzz bomb, copy of German Phi-1 flying bomb, pulse jet, not rocket. University research, Caltech, MIT conducting small-scale liquid fuel tests. Production experience, 0 operational liquid fuel rockets. Britain, RP-3 rockets, solid-fuel aircraft rockets, effective but simple. Research, minimal liquid fuel research, no operational programs. Response to V-2, no defensive capability, rockets too fast to intercept. Soviet Union, Katyusha, solid-fuel artillery rockets, effective but primitive. Research, some liquid fuel research but far behind German progress. German scientists had every reason for confidence. They'd spent 13 years, 1932 to 1945, developing rocket technology with massive government funding. Allies had small university programs with minimal budgets. Dr. von Braun wrote in a classified report, March 1945, German rocket technology represents 15 to 20-year advantage over any other nation. The engineering challenges we've solved, supersonic aerodynamics, liquid fuel combustion stability, high-speed turbopumps, guidance systems require not just funding, but accumulated knowledge that takes decades to develop. Even if enemy captures our facilities and documents, they lack trained personnel and industrial infrastructure to utilize this knowledge effectively. German dominance in rocket technology is unassailable. This assessment seemed completely reasonable, but it was completely wrong. While German scientists congratulated themselves, American engineers were quietly building a foundation that would allow them to exploit captured German technology immediately. California Institute of Technology, Guggenheim Aeronautical Laboratory, GALCIT. Established 1926 as Guggenheim Aeronautical Laboratory, rocket research began 1936. Director Dr. Theodor von Karman, Hungarian-born aerodynamicist. Funding, initially private, military funding from 1939. Staff will say 40-plus scientists and engineers by 1944. Research focus, 1939 to 1944. Liquid fuel rocket engines. Small-scale tests achieving stable combustion. Supersonic aerodynamics. Wind tunnel tests of projectiles at Mach 2 to 3. Propellant chemistry testing various fuel combinations. Combustion chamber design, solving cooling and stability problems. Guidance systems, primitive gyroscopic guidance development. The research was nowhere near V-2 sophistication, but it created trained personnel who understood basic principles. Dr. Helen Williams, who joined GALCIT in 1942, described the program. We weren't trying to build V-2. We didn't know V-2 existed yet. We were solving fundamental problems. How to achieve stable combustion in liquid fuel engines, how to cool combustion chambers that reach 5,000 degrees Fahrenheit, how to pump fuel at rates needed for significant thrust. Our rockets were tiny compared to German V-2, but we were learning principles that would let us understand German technology when we captured it. Jet Propulsion Laboratory. GALCIT reorganized as JPL 1943. Military contracts development of JATO, jet-assisted takeoff rockets. Production, solid fuel rockets for assisting aircraft takeoff. Budget, $3 million annually, tiny compared to German programs' $500 million. Key American advantage. American research emphasized a systematic engineering approach rather than a single massive project. Document everything, publish results within security restrictions. Train large numbers of engineers, build industrial production capabilities, create testing infrastructure. By 1944, America had 200-plus engineers with rocket experience. TEST stands for evaluating engines. Wind tunnels for supersonic testing. Production facilities for solid fuel rockets. Military/industrial coordination infrastructure. This foundation seemed trivial compared to the German V-2 program, but it was exactly what would allow rapid exploitation of captured German technology. As Germany collapsed in April-May 1945, American and Soviet forces raced to capture German rocket technology and scientists. The prize: Peenemünde Research Facility, Main Development Center. Nordhausen Production Facility, underground factory, 6,000 V-2s produced. 14 tons of documents, complete technical drawings, test results, production records, 100-plus rocket scientists, world-leading experts in every aspect of rocket technology. Captured hardware, 100 complete V-2 rockets plus thousands of components. Operation Paperclip, U.S. operation. Named Paperclip because paperclips attached to files identified scientists for capture. Duration, May to September 1945. Objective: capture German rocket scientists and technology before Soviets. Commander: Major Robert Staver, U.S. Army Ordnance. Priority targets: von Braun and top 100 rocket engineers. The surrender. May 2nd, 1945, von Braun and top engineers surrendered to U.S. forces. Reason: preferred American captivity over Soviet, feared execution or harsh treatment. Package deal: von Braun negotiated for entire team, 127 scientists. Documents: von Braun had hidden 14 tons of documents in a mine shaft, revealed location to Americans. Hardware: Americans captured 100 complete V-2s being shipped to Nordhausen. Soviet capture: what Soviets got: Peenemünde facilities partially destroyed, lower-level technicians, production equipment. What Soviets missed: top scientists, complete documentation, most intact rockets. The American operation was a masterpiece of intelligence and speed. Within weeks, German scientists and hardware were en route to the United States. But moral complications were enormous. Operation Paperclip required making deals with men who had Nazi pasts, some deeply compromising. Dr. Wernher von Braun, Nazi Party member, joined 1937, required for position. SS membership, honorary SS major, 1940. Slave labor, V-2 production used 20,000 concentration camp prisoners at Mittelwerk factory. Deaths: estimated 12,000 prisoners died from harsh conditions during V-2 production. Von Braun's defense: I was an engineer focused on space travel. Rockets were a military application, but my dream was always space exploration. Nazi Party membership was a requirement for continuing research. I had no direct involvement in labor conditions at production facilities. I deeply regret civilian casualties from V-2 attacks and prisoner deaths in factories. American decision: the U.S. government faced a difficult choice. Option A: prosecute German scientists as war criminals. V-2 killed 5,000 plus civilians. Production killed 12,000 prisoners. Option B: grant immunity in exchange for rocket expertise, preventing Soviets from capturing knowledge. They chose option B, but with extensive background sanitization. Paperclip processing: investigation, background checks on each scientist. Sanitization: removing or downplaying Nazi affiliations in files. Visa processing: bringing scientists to U.S. as specialists. Public relations: presenting scientists as refugees rather than former Nazi engineers. The decision remains controversial, arguments on both sides. For immunity: rocket knowledge was critical for national security. Preventing Soviet acquisition of technology justified compromise. Most scientists were engineers, not policymakers. Prosecuting them wouldn't undo past atrocities. Their expertise advanced peaceful space exploration. Against immunity: made deals with men complicit in war crimes, undermined moral authority from Nuremberg trials, rewarded perpetrators while victims got no justice, sent message that expertise excuses complicity, created precedent of overlooking atrocities for strategic gain. Dr. Helen Williams, who worked with von Braun team starting 1945, described her conflicted feelings. I was excited to work with the world's leading rocket experts. Then I learned about Mittelwerk. 12,000 people died building rockets these scientists designed. Now I was supposed to work alongside them like nothing happened? But refusing wouldn't bring victims back, and the knowledge existed. Question was whether America or Soviets would use it. I made peace with working with them, but I never made peace with what they'd been part of. That tension never resolved. White Sands Proving Ground, New Mexico, October 1945. American and German engineers worked together assembling captured V-2 rockets for test launches. The Germans were prisoners of war in everything but name, restricted to base, monitored constantly, working under American supervision. Project Hermes. Objective: test fire captured V-2 rockets to understand technology. Location: White Sands, New Mexico, remote desert, 3,200 square miles. Timeline: October 1945 to September 1952. V-2 rockets launched, 67. German scientists involved, 127. American engineers involved, 200 plus. First launch: April 16, 1946. Rocket captured V-2 refurbished at White Sands. Crew mixed American-German team. Altitude achieved 3.4 miles, successful but lower than design spec. Result, rocket broke apart during flight, control system malfunction. Von Braun watched from blockhouse, frustrated. If we had proper facilities, we could have prevented that failure. You're testing rockets with improvised equipment. Major James Hamill, U.S. Army Project Officer, replied coldly, "We're learning from your rockets." "Doctor, not asking your permission. Next launch will be better." And it was. Launch statistics, 1946 to 1952. Launches, 67 V-2 rockets. Successful, 54, 80% success rate. Maximum altitude, 132 miles, February 1949. Payloads, scientific instruments, cameras, biological specimens. Data collected, atmospheric measurements, solar radiation, upper atmosphere composition. Scientific value, established foundation for space science. But more important than launch statistics was knowledge transfer. American engineers weren't just firing captured rockets, they were learning by doing. Joint assembly, Americans and Germans assembling rockets together, Germans explaining each component. Launch operations, Americans learning countdown procedures, control systems, telemetry. Failure analysis, post-launch analysis teaching what went wrong and why. Documentation translation, 14 tons of German documents translated and studied. Design discussions, American engineers asking why on every design decision. By 1948, American engineers understood V-2 thoroughly. Now came next step, improving it. American engineers quickly identified V-2's limitations and began designing improvements of two problems. Guidance, gyroscopic system was primitive, accuracy only plus or minus 3 miles. Fuel efficiency, alcohol-water fuel was inefficient. Warhead, too small for nuclear weapons. Atomic bombs were much heavier than conventional warheads. Range, 200 miles, insufficient for strategic weapons. Reliability, 20% failure rate too high for military use. American improvements, 1948 to 1952. Corporal missile, based on V-2 but completely redesigned. Better guidance, radio command guidance, accuracy plus or minus 300 feet. Nuclear capable, designed for tactical nuclear warhead. Mobile, could be transported and launched from mobile platform. Production, 1,000 plus missiles, operational 1954 to 1964. American rocket programs failing. Vanguard explosion, December 1957. Soviet technological superiority. Redstone missile. Direct V-2 descendant, von Braun team's design. Longer range, 200 miles, 350 miles. Better guidance, inertial guidance system. Nuclear capable, 39 nuclear warhead. Reliable, 95% plus success rate. Later modified to launch America's first satellite, Explorer 1, 1958. Jupiter missile. Medium-range ballistic missile, 1,500 miles. Fully American design, incorporating lessons from V-2. Deployed Europe 1958 to 1963 as nuclear deterrent. The evolution was clear. V-2 Redstone Jupiter Saturn V moon rocket. Each generation built on previous, but American engineers were now innovating beyond German starting point. October 4th, 1957, Sputnik. The Soviet Union launched Sputnik 1, the first artificial satellite. The world was shocked. America seemed behind in the space race, but appearance was deceiving. What the public saw, Soviets' first to orbit satellite. What engineers knew, American military had deliberately delayed the satellite program. Von Braun's team had a satellite ready to launch in 1956. The government prioritized military missiles over a civilian space spectacle. American rocket technology was actually more advanced, just focused differently. Explorer 1, January 31st, 1958. Launch vehicle, Juno 1, modified Redstone von Braun design. Payload 30.8 pounds versus Sputnik's 184 pounds. Scientific value, discovered Van Allen radiation belts. Significance, proved American capability and superior instrumentation. The space race was officially on, and it would culminate in achievements German scientists thought impossible. May 25th, 1961, Kennedy's moon speech. I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to Earth. The audacity was breathtaking. America's total spaceflight experience, 2 suborbital flights, 15 minutes each. Kennedy was committing to land men on the moon within 8 years. Saturn V development. Director, Dr. Wernher von Braun, now American citizen, NASA Marshall Space Flight Center Director. Design team, mix of original German engineers, now in 50s to 60s, and American engineers, mostly in 20s to 30s. Objective, build a rocket powerful enough to send a 100,000-pound spacecraft to the moon. Saturn V specifications. Height 363 feet, taller than the Statue of Liberty. Weight 6.5 million pounds, loaded. Thrust 7.6 million pounds. First stage 190 times more than V-2. Payload to moon 100,000 pounds. Stages 3 liquid fuel stages. Cost $185 million per launch, $1.5 billion in current dollars. Reliability 13 launches, 12 successes, 92%, 1 partial failure. Technological leap. V-2 to Saturn V represented an incredible advance. Thrust increase 56,000 pounds, 7,600,000 pounds, 135 times. Payload capacity 2,200 pounds, 260,000 pounds to orbit, 118 times. Guidance accuracy, plus or minus 3 miles, plus or minus 1,000 feet, 95% improvement. Reliability, 80%, 92%. Complexity, 1 stage, 3 stages, multiple engines per stage. Von Braun led the design, but American engineers were now equal partners. German scientists who'd laughed at American capabilities in 1945 now relied on American engineering, manufacturing, and systems integration expertise. July 20th, 1969, Apollo 11. Neil Armstrong stepped onto the lunar surface. That's one small step for man, one giant leap for mankind. The achievement vindicated 24 years of rocket development, starting with captured V-2s. But it also demonstrated how far American capabilities had evolved beyond the German starting point. Saturn V versus V-2 comparison. Technology heritage, V-2 principles, liquid fuel stage design, gyroscopic guidance. But evolved. Computer guidance, multiple engines, restartable upper stages, orbital mechanics calculations, life support systems, landing systems. German contribution. Foundation, basic principles, key engineers. American contribution, manufacturing capability, systems integration, computer technology, massive scaling up, operational doctrine. Dr. von Braun, watching Apollo 11 from Mission Control, was interviewed. The V-2 was beginning, crude, limited, but it proved principle. Today we landed on Moon using rockets that incorporate V-2 heritage but have evolved far beyond anything we dreamed in Germany. American industrial capability, engineering talent, and national commitment achieved what German scientists alone never could. I contributed knowledge. America contributed everything else, and that made difference. The rocket program's success came at enormous human cost, most paid before Americans ever captured V-2. Mittelwerk factory deaths. Location: underground facility in Harz Mountains. Workers: 20,000 concentration camp prisoners. Deaths: approximately 12,000 from exhaustion, starvation, beatings, executions. Working conditions: 18-hour shifts, minimal food, no medical care, brutal overseers. Production: 6,000 V-2 rockets. Moral calculation: 2 prisoners died for every rocket produced. V-2 combat deaths. Civilian deaths from V-2 attacks, approximately 5,000, mostly London. Military deaths, approximately 500. Total deaths from V-2 program, approximately 17,500. Production plus combat. The moral reckoning. After the war, survivors and relatives demanded accountability. The scientists who designed these rockets knew prisoners were dying to build them. They visited factories. They saw conditions. Yet they continued designing, improving, demanding higher production. Then after war, they came to America as heroes. Where is justice? Dr. Helen Williams, who worked with von Braun team but struggled with moral implications. I justified working with them by saying, knowledge exists. We can't unknow what they discovered. Better we use it than Soviets. But that doesn't absolve them or us. Every time Saturn V launched successfully, I thought about prisoners who died making V-2s. The technology that put men on moon has foundation of corpses. That's truth we can't escape. Von Braun himself gave various responses over the years, never fully satisfying critics. 1945, I was engineer, not policymaker. 1950s, I deeply regret deaths of prisoners, but I had no authority over factory conditions. 1960s, if I'd known extent of suffering, I don't know what I would have done. Probably same thing. 1970s, I carry guilt for what happened at Mittelwerk, but I can't undo it. Best I can do is ensure space program has peaceful purpose. The moral complexity never resolved. Rocket program success was built partly on knowledge gained through atrocities. No amount of later achievement erases that history. Operation Paperclip statistics, 1945 to 1959. Technical papers published, 5,000 plus. Engineers trained by German scientists, 10,000 plus. American scientists, engineers who learned from V-2 program, 50,000 plus. German scientists brought to US, 1,600 plus. 127 initially, expanded to include specialists in other fields. Rocket scientists specifically 127. Cost to US, $200 million, relocation, salaries, facilities. Value to US programs, incalculable. Foundation for space program, missile development, jet propulsion. V-2 program legacy of 2 rockets captured, 100 complete rockets, thousands of components. Of 2 launches at White Sands, 67. American rocket programs derived from V-2, Redstone, Jupiter, Saturn family. Ultimate achievement, Saturn V moon rocket. Time from V-2 capture to moon landing, 24 years. Scientific output. Patents filed by former German scientists in US, 1,000 plus. Strategic impact. ICBMs developed using V-2 knowledge, Atlas, Titan, Minuteman. Nuclear deterrent built on rocket technology derived from V-2. Space program, Explorer, Mercury, Gemini, Apollo, all built on V-2 foundation. Satellite technology, communications, weather, reconnaissance, all launched on V-2-derived rockets. Cost-benefit analysis. U.S. investment in Paperclip, $200 million. Estimated value of captured technology, 10+ billion, 1940s dollars. Time saved by not developing from scratch, estimated 10 to 15 years. Strategic advantage. Nuclear missile capability, 5 to 10 years earlier than otherwise possible. But costs weren't just financial. Moral costs. Justice denied, war criminals granted immunity. Message sent, expertise excuses complicity. Victims forgotten. 12,000 dead prisoners received no acknowledgement. Precedent set, strategic value trumps moral accountability. Smithsonian National Air and Space Museum, Washington, D.C., July 20th, 2019. 50th anniversary of Apollo 11 moon landing. Display featuring V-2 rocket alongside Saturn V model showing technological evolution. Among attendees was Marcus Chen, 67, son of Dr. Helen Williams, died 2004. Also present was Professor Klaus Becker, 78, whose grandfather had been prisoner at Mittelwerk factory, survived the war. They stood before V-2 display, reading placard explaining rocket's history. "My grandfather helped build this," Klaus said quietly. "Not voluntarily. He was prisoner. He was beaten daily. He saw men die of exhaustion. He survived by luck, 12,000 didn't." Marcus nodded. "My mother worked with the scientists who designed it. She told me she struggled her whole life with the moral contradiction, being inspired by the engineering while being horrified by the cost." The placard mentions the prisoners, Klaus observed. 1 paragraph, 12,000 dead reduced to 1 paragraph. Then 3 paragraphs celebrating engineering achievement. "Is that wrong?" Marcus asked. "The engineering achievement was real, but so was the suffering. Both are historical facts." "I don't know," Klaus admitted. "My grandfather had complicated view. He hated what was done to him. But he also said that if you reject everything touched by evil, you reject most of human history. He watched moon landing in 1969. He cried. He said, 'Same knowledge that nearly killed me put men on moon. I hate how it was gained, but I'm glad something good came from it.' They moved to Saturn V display, massive rocket hanging from ceiling. This is one built by Americans and Germans working together, Marcus said. Von Braun led design, but American engineers were equal partners by this point. The knowledge transfer went both ways. Germans taught Americans about rockets. Americans taught Germans about manufacturing scale, systems integration, and mission planning. Did your mother ever meet survivors? Klaus asked. Once, Marcus replied. In 1985, she gave a lecture in Germany about space program. Survivor confronted her afterward, asked how she could work with men responsible for Mittelwerk. She said she had no good answer. Just that knowledge existed, someone would use it. She chose to help ensure it was used for peaceful purposes. The survivor said that wasn't good enough. She agreed it wasn't. But it was all she had. Before leaving, Klaus placed a small memorial placard he'd made at V-2 base for the 12,000 who died building these rockets. Remembered? Marcus placed his mother's NASA service medal beside it. For those who struggled with moral complexity of transforming weapons into exploration. The struggle matters. The story of Operation Paperclip and V-2 technology transfer is ultimately about how captured enemy technology accelerates development, how moral compromises enable strategic advantage, and how laughing at enemy capabilities blinds you to their potential. German scientists laughed at American rocket programs because in 1945, American capabilities genuinely were primitive compared to V-2. The laugh seemed justified by evidence. But German scientists misunderstood American advantages. Industrial capacity. America could build test stands, facilities, manufacturing capability at scale Germans couldn't match. Trained workforce. American universities had produced thousands of engineers who could learn rocket technology quickly. Systems integration. American engineering excelled at taking components and building complete systems. Resources. America had money, materials, and time to develop programs without wartime pressure. Most critically, American engineers had humility German scientists lacked. When Americans captured V-2, they didn't dismiss it as enemy technology. They recognized revolutionary achievement and learned everything they could. The evolution. 1945, Germans laugh at primitive American rockets. 1945 to 1946, Americans capture V-2 technology and scientists. 1946 to 1952, Americans master V-2 through test launches. 1952 to 1958, Americans improve on V-2, develop Redstone and Jupiter. 1958 to 1961, Americans build foundation for space program. 1961 to 1969, Americans develop Saturn V, 135 times more powerful than V-2. 1969, Americans land on Moon using technology evolved from V-2. The moral complexity. Operation Paperclip remains controversial because it required moral compromise, granted immunity to men complicit in atrocities, prioritized strategic advantage over justice, used knowledge gained through suffering, but it also prevented Soviet acquisition of German scientists, enabled American nuclear deterrent, made space exploration possible, transformed weapons technology into peaceful exploration. There's no clean resolution. The moon landing was genuine achievement, but it built on foundation of suffering at Mittelwerk. Both facts are true. History holds both. Dr. von Braun stood at Peenemünde, May 1945. Confident Americans couldn't utilize captured V-2 technology. 24 years later, he stood at Mission Control watching Saturn V, his design, but evolved far beyond V-2, land Americans on Moon. His confidence in 1945 was based on German technological lead, but he failed to account for American capacity to learn, adapt, and scale up. The country with primitive rocket programs in 1945 landed on Moon in 1969. The lesson? Never laugh at enemies' current capabilities. They might capture your technology, learn everything you know, improve on it, and achieve things you thought impossible. German scientists laughed at American rockets. Americans captured V-2 secrets. Within a generation, American rockets evolved so far beyond V-2 that lunar landing became reality. Sometimes, the most devastating response to being laughed at is to learn everything from those who laugh, then surpass them so completely that history forgets they ever had advantage. German scientists laughed at American rockets, American engineers learned from German rockets, and American astronauts walked on Moon using technology that started with V-2, but evolved into something far greater. The laughing stopped. The learning never did.